Can you see the screen?
I can.
All right, number 12 here. Find an equation for the line tangent to the curve at the point defined by the given value. Also find the second derivative. Whenever you're doing derivatives to find these slopes, it's just that formula. I should have the formula in front of me, but I don't. I think it's just dy dt divided by dx dt.
Yeah, I'm pretty sure that's what it is too.
Yeah. All we have to do is just take the derivatives of the y function and then of the x function, take the ratio of those two things, and then plug in the point here. So derivative of y, derivative of 8 sine t is 8 cosine t. But we need to plug in that point negative pi over 4. And cosine of negative pi over 4 looks like it's negative square root 2 over 2. No, positive. Sorry. Positive square root 2 over 2. So this is just going to be 4 root 2. Okay. Dx dt, the derivative of x is going to be negative 8 sine t. And then plugging in the negative pi over 4, that one's negative root 2 over 2. But it's going to cancel out with the negative that's already up here. So this is also going to come out to be positive 4 square root 2. And then the ratio of those two things would be the 4 square root 2 divided by 4 square root 2. So it looks like we just get 1. Okay, but that's the slope, right? That's my m value, and then we have to plug it into the point slope form. This thing, the y minus y1 is equal to m times x minus x1. We do need to find the x1 and the y1 because they do not give it to us in the problem. And to find that, we're just plugging in the negative pi over 4 into the original x and y. So we're going to do 8 cosine of negative pi over 4, and then that with the 8 sine of negative pi over 4. And again, just looking at unicircle stuff, that's going to be 4 square root 2 for x, negative 4 square root 2 for y. Okay, so yeah, that's just plugging in, right, the t value into the x and the y as is.
Okay.
So that's going to be my x1 and y1, which means that my equation is going to be y plus 4 root 2. And that's going to be equal to my slope, which was m, times x minus the x, 4 root 2. And you could probably just type it in just like this. Of course, you could subtract the 4 root 2 over if you really wanted to, but I don't know. There's no point. Yay. All right, so that's usually the easier part. It's the second derivative that can be kind of weird. So if we want to do the second derivative in this parametric form, that's going to be the derivative of the derivative with respect to t divided by dx dt. All right, so we already have a dx dt. We just need to find the derivative of the derivative, which was this thing that we had gotten. Oh, we didn't even write it out, right? We just go ahead and plugged in the points. We're going to have to take this ratio. The 8 cosine t divided by the negative 8 sine t. So the negatives, the 8s will cancel out. We're just going to end up with negative cosine of t divided by sine t. Or we could write this as negative cotangent t. Same thing. But that was, sorry, I'm messing up my notation here. That was just the derivative y prime, right? Y prime is the same thing as dy dx. So dy dx was that ratio that we got, the 8 cosine divided by the negative 8 sine. Now we have to take the derivative of that. So dy prime dt. Derivative of negative cotangent, I think, is positive cosecant squared. I'm pretty sure that's right. So the negatives would cancel, and then cotangent goes to the cosecant squared. So that means that my second derivative of y with respect to x is going to be that cosecant squared in the numerator divided by the dx dt, which was the derivative of x from over here, the negative 8 sine of t. And then maybe that can simplify down a little bit. I don't know. It doesn't really matter because we're plugging in the point again, the negative pi over 4 thing. So if we plug in negative pi over 4 into cosecant, it's normally root 2 over 2, but it's going to be that inverted or reciprocaled and squared. So let's see. It's going to be negative 2 over root 2, which is just root 2. But it's going to be that value squared. So that's in the numerator. That's going to be divided by the negative 8 times the negative square root 2 over 2 in the denominator. All right, so my numerator is going to square out just to be a positive 2. My denominator, that's going to be that positive 4 square root 2 that we saw from before. So all in all, we're going to get a 1 over 2 root 2. And I'm sure this could, of course, be simplified a little bit better, but I'll probably just leave it like that. Hopefully the homeworks will take it. Yeah, they did. So yeah, sorry that was kind of all over the place and I was messing up my notations there, but is that all right? Did that help?
Yeah, it makes a lot more sense now.
Okay. Yeah, so the problem is that there are formulas here for these parametric stuff. So our normal derivative, the slope thing, this dy dx, is the ratio of the derivatives of the y parameter function and the x parameter function. So we just found those separately, took the ratio. Once we came down to where it asked for the second derivative, again, it's just kind of a weird formula. It's the derivative of y prime, where this y prime is really the dy dx thing. So we had to take the ratio, take the derivative of that, plug that into the numerator, and then divide that by another dx dt. And then plug in that same point, the negative pi over 4. So was that it? Was that the only homework question you had?
That was my only one, but I think Josh joined.
Yeah, I see that. Josh. Hi, Josh. Do you have any homework questions you want to look at? Oh, geez. That's not good, Josh. Did you two get my email about that thing tomorrow?
Yeah, with that Kate Morgan girl.
Yeah. It sounds like she's really trying hard to put something pretty cool together. If you have the time, I'd recommend going.
Definitely.
Well, if you don't have any other homework questions, I did put up the other stuff due for next week now. The rest of chapter 11.
How many sections are in 11?
We're just going to do the first 5. Sections 3 and 4 are very small. Section 5 is a little bit bigger, probably take a little bit more time, but hopefully you'll be able to knock those out fairly easily. And then I went ahead and put up our last test as well, the Chapter 11 test, for the first week of May, which is also going to be the week of the final exam. So I'll probably have the final exam due. This is due on like a Monday, I think. Yeah, and then I'll have the exam due that Friday. It'll give you a few days to review and look over everything. So we're getting close to the end of the semester. We only got a couple more weeks left.
That's great.
I know. It's been a pretty wild semester. A final review. I think I do have. Let's see what I got. I think I do have a final exam review in my folder here. Yeah, final practice stuff. And then I have the solutions to it. And then here you go, practice final. Yeah, so I'll be emailing this out here pretty shortly. I'm going to have to put it into a format that you guys can actually open up, but I think this is a pretty good review. Unfortunately, I'm going to have to make a new final that's an online final for you guys, but I'll make sure it's following along with this review fairly closely. And it's definitely not going to be as long. Like, I don't know if you saw, but that thing had like 40 questions to it. Your final exam might have half of that.
So it'll be about as long as the chapter 10 test, 20 questions ish.
Yeah, it's going to be about the same size. I think this chapter 11 test coming up is a little bit shorter. There's only 14 questions I put on that one, but only because chapter 11 is so much smaller than chapter 10 was. Was there any last questions then? I mean, we don't have to stick around if you guys don't have homework questions. I'm sure you'll have more next week when you get into the rest of the chapter 11 stuff. Some of that can be hard.
I'm good right now.
Josh, you all right? Any other last questions? Okay. Well, I appreciate you guys coming. I hope you go to that thing tomorrow. And then otherwise, I'll do another one of these next Tuesday. All right. Thanks for coming. Bye. Have a good weekend. Do your homework.